So in this basically we'll discuss about this time period of satellite. So we are going to find out what about the value of time taken by a satellite to complete one full revolution. So if you are considering that if a satellite is revolving around a planet, and let's end in the last part we discussed with what velocity it is going to move. So the velocity with which a satellite is revolving around a planet, we consider it as nothing but its orbital velocity. So let's say this satellite is moving with a velocity, let's say that is equal to VO, where VO is representing the orbital velocity, and take it as RO is representing the radius of the circular orbit. So we can find out what about the value of its time period. So we are just using our normal equation, that is velocity is equal to displacement by time. So we can write the equation for its time is equal to nothing but displacement by velocity. Now I'm just representing this time period by capital letter T, and when a satellite complete one full rotation, we know that the distance traveled by this is equal to nothing but the value of circumference of circular path, which we can take it as nothing but 2 pi into r naught, divided by, in the last part we discussed about this orbital velocity, and the equation for orbital velocity is nothing but root of gm divided by r naught, where g is universal gravitational constant, m is mass of that planet around which this satellite is moving, and r naught is nothing but orbital velocity. So if you are substituting this value over here, we can write it as 2 pi r naught into under root of gm divided by r naught. So we can just rearrange this equation in this form. This is equal to nothing but 2 pi into under root of, so if I'm just taking this r naught inside the root, then we'll get as nothing but r naught square divided by, we can take it as gm, and this r naught will come on, this r naught will come on numerator. So we'll get the equation for time period is equal to 2 pi into under root of r naught square into r naught, which we can take it as r naught cube divided by gm. This is the equation for time period. So if you would like to find out the value of time period, we can use this equation. Now if we are squaring this equation on both the sides, so we can write this is equal to t square, and which is equal to nothing but 2 pi into under root of r naught raised to 3 divided by gm, the whole square. So if you are squaring, we'll get it in this form, that is t square is equal to square of 2, we can take it as 4, pi we can take it as pi square, and this becomes r naught cube divided by gm. So this is the relation between t square and r cube, and if all these other parameters are constant other than time period and radius, so we can say that this square of time period is equal to nothing but r naught raised to 3. So in later we'll discuss about the same equation under the heading Kepler's law. So you might have heard that according to Kepler's third law, the square of time period is directly proportional to cube of radius.